Hi, my name is Soren. Welcome to this presentation about aesthetic durability of concrete structures. The aim of the presentation is to put focus on the challenge of aesthetic durability of concrete structures, and especially the challenge of keeping white or light-colored concrete structures aesthetically pleasing over time. What are the changes happening to concrete structures because of weathering effects, and what can we do to compensate for this? White concrete buildings have been built for many years, but more so during the last 2 or 3 decades. Unfortunately, after not too many years, some buildings do not maintain the original intended aesthetic appearance. Weathering effects have changed the building. I have divided the presentation in 3 parts. To start, I will show some examples of concrete structures with good and bad aesthetic appearance. Then a more detailed explanation of what had caused the concrete surfaces to change, especially how weathering effects have affected the concrete over time. And at the end, I will try to give some answers to the question, can we do something to improve the aesthetic durability? But first, this is how a concrete building is supposed to look, clean and without any discoloration or damages. This building is constructed of precast elements of polished white concrete. Another example of an aesthetic pleasing concrete facade. Here it's in situ cast light gray concrete. And these are pictures of the beautiful cathedral named Our Lady of the Angels in Los Angeles. We see some variations in the color of the facade, but because of the breakup of the large facade surface into smaller elements, this variation tends to be hidden. This in situ cast concrete has a warm golden color obtained by using a yellowish sand together with white cement. The last example of an aesthetic pleasing structure is this house with clean light colored concrete roof tiles and rendered walls. But it is not always that a concrete structure maintains its originally intended aesthetic appearance. This picture speaks for itself. We can see how the light colored concrete elements have become discolored, especially the concrete just below the roof and under the windows. Another example of bad aesthetic durability. The surface of this spray-rendered facade is severely discolored. This is concrete elements with a brushed surface texture where the growth of red algae have radically changed the appearance of the building. Here we see a tall construction in light-colored concrete elements. The lower building in the front, the staircase and parapet, shows strong discoloration running from the top and down the concrete. Also, the top part of the tall building have a dark discoloration. Residential buildings in yellow precast concrete elements. Just under the roof eave, the concrete looks pristine, but further down, growth of algae are seen in a characteristic streak pattern. And finally, this example of concrete elements that no longer appears nicely light-colored. This was some examples of how concrete structures not always maintain the intended appearance. In the next part of my presentation, I will go through the causes behind the alteration that happens to concrete surfaces when the concrete structures get older. First, we need to learn a little about how concrete is composed. Looking at a concrete surface from a distance, it looks fairly uniform in color. But in fact, concrete is composed of different materials which can be seen when cutting through the concrete. It always contains as minimum cement paste, sand, and coarse aggregate. The 4 tiles shown on this slide exemplifies the color changes when changing the concrete components. The tiles are based on wet cast concrete, and the surfaces we see are the mold-side surfaces. Tile number 1 is based on gray cement, gray sand, and dark stone. For tile number 2, the gray cement is replaced by white cement. For tile number 3, also the gray sand has been replaced by white sand. And finally, for tile number 4, we have white cement, white sand, and also white stones. We see that it's not only the choice of cement that determines the color. Different shades of white are possible with different sand and aggregates. The reason for the different shades is of course that the concrete surface is in fact not uniform, as can be seen from this schematic illustration of a magnified piece of concrete. Even on a smooth fair-faced concrete surface, the color is not uniform. Looking closely, the color is a mix of the reflections coming from both the cement paste, the sand, the stones, and also any air bubbles or irregularities in the surface. The cement paste is also slightly transparent, so dark stones covered by a thin paste layer can be seen as a shadow underneath the surface. The color of sand and aggregates are even more visible for concrete that has a polished or exposed surface. This picture shows one concrete tile where 1/3 of the surface is left untreated, 1/3 is polished, and the last third washed so that the aggregates are exposed. It is seen how it's possible to obtain a large variety of surface colors and textures. With this information in mind, we can have a look on what happens when a concrete surface is affected over time by weathering effects. In this illustration, the darker particles are sand grains, and in between are cement paste and air voids. On the top is shown a white thin layer of cement paste. This layer is known as cement skin on a wet cast concrete surface. Weathering effects are coming from the action of heating and cooling, rain and snow, and also airborne dirt particles. Let us see what happens. First, the thin layer of cement skin quickly erodes away. Then the erosion continues on the cement paste, leaving the harder sand particles partly exposed. Sand particles become more visible, and cracks and air bubbles will be open. The appearance of the surface changes. Erosion on a real concrete surface can look as shown here, from a pristine surface to a now darker surface with visible open air voids. An example of heavy erosion are 3 thaw damages on a concrete slab. The picture shows spalling due to such actions on an old paving stone next to a new paving stone. An eroded surface having open air voids and cracks will easily pick up dirt and get soiled. Some dirt will be washed away by rain, but the rain will also make the dirt penetrate further into the larger pores. Eventually, we have an eroded and soiled concrete surface. And on real concrete, it can look like this. Dirt deposits onto concrete surfaces are very visible on these pictures, showing a rendered facade and a road barrier. Horizontal surfaces will usually collect much more dirt than vertical. Especially in humid climates, weathering also includes fouling effects. Depending on sunlight, temperature, and moisture conditions, different lichens and algae will grow on the concrete surface. A wet eroded surface gives an excellent foothold for lichens and algae to grow. It is worth to notice that lichens will often grow on the cement paste, but not on exposed aggregates. On a real concrete, it looks like this. The picture to the left shows a building where the corner elements are made of white concrete. The building is more than 50 years old. From a distance, the corner element still looks reasonably uniform in color, but coming close, it is evident that the surface is covered with lichens, fungi and algae in symbiosis. And this is how bad it can be on a horizontal, meant to be white concrete surface. A lot of lichens and dirt. The growth of lichens is a relatively slow process, but under the right conditions of sunlight, temperature, and moisture, lichens can flourish. What I have shown so far can be considered as the normal consequences of weathering, which are merely aesthetic consequences. Other and often more deleterious effects which alters concrete surfaces are lime efflorescence, spalling from reinforcement corrosion, and cracking from alkali-silica reaction. Efflorescence and reinforcement corrosion are shown here. Lime efflorescence is not often seen on facades because it requires that water have been in contact with non-carbonated concrete for a longer period of time. Then it is possible for calcium to dissolve and reprecipitate. A good example of this is paving blocks stacked on pallets. Here water are held for a long period in between the blocks, and lime is very often seen to precipitate. Corrosion of iron reinforcement happens when the pH in the concrete is in contact with the reinforcement lowers because of carbonation. This happens if the concrete layer covering the reinforcement is too thin. Due to the increased volume of the corrosion products, the concrete cracks or spall off as seen in the middle picture. I also mentioned alkali-silica reaction. This is not a consequence of weathering, but degradation because of poor concrete containing aggregates with reactive amorphous silica. Reaction between the amorphous silica and alkali from the cement are causing expansion and subsequent cracking of the concrete. This is in fact not only an aesthetic problem, but a more severe structural problem for the concrete structure. Now we have seen how concrete surfaces can change over time, and it is inevitable that the aesthetic appearance of concrete structures change over time. But being aware of this, we have means to limit the changes and improve the aesthetic durability. There are 4 focus areas in order to improve aesthetic durability. The first begins already when the buildings are designed. Secondly, there is the concrete mix design. Thirdly, post-treatment of surfaces. And last, maintenance. Design of a structure and the influence of weather have to be envisaged on 3 levels. General shape and placement of the structure. What is the local wind patterns, shading from other buildings and vegetation, and local wind conditions. Detailing on the structure. That relates to localized runoff patterns for rainwater and staining from other materials. It includes the engineering design. And last, surface texture. That mainly relates to the ability of the surface to absorb water and the possibility for dirt to be attached. The 3 levels are exemplified by these 3 pictures. This is an 11-story building, more than 50 years old. On a tall building like that, wind and rain will rise to the top by the air current, and it is predominantly the top part of the building that gets wet. In a damp climate, that means that growth of lichen and dirt staining are likely to start at the top. Tall building will always get more rain on the top part of the facade and on the corners due to vortexes. The prevailing wind direction on this location is from the west. Therefore, the east side becomes less wet and shows less growth and discoloration. West, north and south have much more growth of lichens, and the top 5 to 10 meters are clearly stained. This is another tall building, also approximately 50 years old. It is a hospital in Copenhagen. These concrete elements are flat with a smooth surface without any real detailing. At the top of this almost 100 meters high building, you also see dirt and probably growth of lichens. But again, not on all sides of the building. The shape of the building are forming vortexes and shelter for the rain. Wet and humid concrete gives good condition for fouling with lichens. But when rain is prevented from hitting the concrete surface, this do not necessarily mean that the surface will be pleasant. This is seen on this picture where a balcony protects against the rain. The first facade element below the balcony are dark due to dirt not being washed off. The second element is less dark and the third is the cleanest. This is where rainwater can hit the concrete and wash away the dirt. We also see how water from the windows run over the windowsill and onto the elements. And finally, we can see how cold and warm zones on the elements lead to different degree of dirt accumulation. Again, dirt deposit under a balcony that is not washed away by rain. A rough and porous surface will accumulate a lot of dirt. A classic mistake when designing windows are insufficient window sills. The purpose of a sill is to prevent rainwater to penetrate the wall below the window, but also to lift away the running water from the facade so it will not discolor the concrete. In these pictures we see how the sill do not prevent the water from running down the facade at the ends of the sill. Dirt will be accumulated on all vertical surfaces. Water coming from there will carry the dirt. So inappropriate protection from water running from a roof will bring dirt down the facade. Protection with an arras or metal sill are possible solutions. Just make sure that all joints are tight. For buildings where the facade are clattered, like in this case with glass fiber reinforced concrete boards, a solution could be to design so rainwater will run on the back side of the facade elements, going through the joints between the boards. As conclusion, when designing buildings or structures, be aware of dirty water coming from horizontal surfaces, water from window areas, surface areas that are not washed by rainwater, but also surface areas with fast running or slow running water, and gullies through which dirty water can be canalized. Our next possible step in order to improve aesthetic durability is concrete mix design. It is the accumulation of dirt and growth of lichens that are our biggest problems. So can we make the concrete less susceptible to dirt and growth of lichens? One way to evaluate the effect of different mix designs is to place concrete samples outdoor and follow the change over time. This has been done in Aalborg, Denmark. Tiles made of concrete with different formulations and cast in different mold types have been followed for more than 10 years. I will quickly go through our findings. The water to cement ratio in a concrete is determining how strong the concrete is, and more important for us, how porous it is. From the picture you can see that the amount of dirt and lignins is less if the water cement ratio is low, meaning strong and less porous concrete. Water repellence, that is the ability of the concrete to repel water. Similar as pouring water on a dock, we can make the concrete repel water. This is done by using a hydrophobic admixture in the concrete. Also here we see a beneficial effect. Another thing we can put into the concrete is photocatalytic titanium oxide. Now that is a fairly new invention, also known as self-cleaning concrete. The right titanium oxide together with UV radiation from sunlight can promote the breakdown of organic and inorganic pollutants on the concrete surface. The decomposed pollutants will be washed off by rain. At the same time, titanium oxide is also a white coloring pigment, so it will contribute to the whiteness of the concrete. One small disadvantage is that the photocatalytic titanium oxide turns a little yellow over time. Mold material and surface smoothness. Two different types of mold material, raw wood and plywood, have been investigated. Raw wood gives a little profile or texture to the surface and also a more porous concrete surface that will absorb more water. CPF liners, which is short for controlled permeability formwork, are another way to secure a dense surface with low water absorption ability. Curing time. Longer curing time means stronger surface. To summarize, in order to improve aesthetic durability, we need a strong surface, a closed or non-porous surface, a water-repellent surface, a smooth surface, and maybe also photocatalytic titanium oxide will help. When the concrete are in place or have been demolded, then post-treatment is possible. Post-treatment are usually coatings or impregnations applied in order to give a water-repellent effect. Impregnation are done with transparent liquids or gels consisting of silane or siloxane compounds. The water-repellent effect is clearly recognized on the top picture. One important thing to be aware of is that some impregnating products can make the concrete surface more sticky. So it repels the water, but dirt sticks to the surface anyhow. This graph shows results from outdoor exposed concrete tiles, a gray and a white tile, and one white tile that has also been surface impregnated. What you can see is that from 2006 to 2016, the whiteness of the tiles drops a lot, but the impregnated tile stayed less affected. Maintenance is the last of my 4 focus areas in order to minimize weathering effects. Maintenance of a structure in our case aims to preserve or recreate a desired aesthetic expression. Cleaning is the most obvious way to regain the aesthetic impression of a building. However, for tall building, it can be costly. Removing dirt by cleaning only a part of the surface will create a clean spot that contrasts with the remaining surface. This clean spot cannot be removed, so the only option is always to clean a whole segment or side of a structure. If not done gently, most cleaning methods damage the surface to some extent by removing part of the skin layer of paste and changing the texture. The method least likely to damage the surface is hand washing with luke water and possibly a mild soap. Cleaning can also be done using high pressurized water, chemicals, sandblasting, and steam. When cleaning with chemicals that dissolve staining, it is advisable to use an absorbent paste together with the chemical agent, or to use the chemical in the form of a foam paste. This prevents the dissolved dirt from being absorbed by the pores in the concrete, thereby transporting the dirt further into the concrete surface instead of removing it. An example how cleaning can bring back the aesthetic impression is seen on these pictures. Note the difference between the cleaned and not cleaned white concrete. Now that concludes the 4 focus areas on how to minimize the effect of weathering: design, concrete production, post-treatment, and maintenance. You have seen that with the right consideration a lot can be done to minimize weathering and hereby improving the aesthetic durability of concrete structures. But we need in advance to foresee that concrete surfaces will change over time and take proper actions in order to mitigate the changes. I hope this small presentation have inspired you to contemplate aesthetic durability whenever you are involved with concrete projects. Thank you so much for watching.